So this is our section on linear inequalities. Linear inequalities, of course, are denoted by this wonderful inequality symbol, which means our answer will be on a number line, and we will be shading the number line according to our answer. Now, our linear inequalities, we're just going to solve them the way you would normally solve a linear function, so you get all the x's on one side, all the numbers on the other. So if I notice here, we're going to work problems from part 1 in the homework. This is number 1. And in number 1, I have two terms that are alike that I can combine. So that's the first thing I'm going to do is I'm going to combine. So I have 3x, and that becomes minus 9. Now I want to move that 9 over to the other side. So we are going to add it. And we will get 9 greater than 3x. Now I divide by 3. And the question becomes, do I have to change that inequality symbol when I divide by 3? And the answer is no. I only change the inequality symbol or flip the inequality symbol if I divide by a negative. Multiply or divide by a negative. Since 3 is positive, I don't have to change it. Now here's the common mistake. Notice the number is first, the letter is second. So people go to the number line and they graph it incorrectly. I need the 3, but if I flip this around, x is less than 3. Now I can graph this correctly on my number line. First thing I have to figure out is what kind of dot it's going to be, whether it's open or solid. And this one's going to be open because it does not have the inequality symbol. And then which way to shade? Well, if I have the variable first, the arrow points the way that I should shade. So I'm going to shade to the left. You can always do what I call a plug-in and check. So I'm going to pick a number smaller than 3. So pick a number right here, 0. If I plug 0 in, is 0 less than 3? Answer is yes. I could also plug in a number over here, 4, 4 less than 3. Answer is no, so I do not shade to the right. I only shade to the left. Okay? Let's do number 6. Number 6. Same thing. First thing I'm going to do is combine like terms, do any simplification that I can, just like you normally would when you're solving for a variable. So 2 minus 4 gives me a negative 2p, less than equal to negative 2. Yes, just like the last time, I'm going to divide by the coefficient, negative 2. Only this time, I'm dividing by a negative. When you divide by a negative, you have to flip the inequality symbol. So I'm going to make a special note here. We flip the inequality symbol because we divided by negative. Negative 2 divided by negative 2 is 1. Okay? So I put 1 on my number line, and this is going to be a solid dot because we have that wonderful equal to sign. And then the arrow points the way. It says shade to the right. So let's check it. I'm going to pick two numbers. So I got 0, then 1, and 2 greater than or equal to 1. Which one is true? Yep, the second one is true, so shading to the right is correct. So we shade to the right. We're going to work one more problem. We're going to work number 11. Okay, number 11 looks really complicated, and actually it's really not. It's the exact same thing we just finished doing. Simple solve, only now I have parentheses, so I need to, you got it, distribute. We're going to distribute that number. So I'm going to leave the left side of the equation alone. Distribute the negative 4. I have 24 minus 12a. Okay, now I need to get letters to one side, numbers to the other. I'm going to add 12a to both sides because that will give me a positive 13a minus 15 greater than 24. Okay, now I need to get rid of the 15. So we're going to add 15. So now I have 13a greater than, that is 39. Okay? Divide both sides by 13 to get a by itself, so a is greater than 3. Put 3 on the number line. What kind of dot does the 3 get? Very good. Open. And now do your check. 2 is to the left. Is 2 greater than 3? No. 4 is to the right. Is 4 greater than 3? Yes. And notice the arrow does point the way, and we're going to shade to the right. The arrow pointing the way, remember, only works If the variable is first, the variable must be first. And this concludes our lesson on linear inequalities.